Similar to an SMO Junior problem back in 2020. So SMO Junior. 2020, I believe. I'm pretty sure it's right. I think it was just a multiple choice question, so it wasn't considered particularly challenging. But you can see it's kind of tedious here. Notice that there's, what is this, 58 integers? So this could actually be cast as a probability question if you wanted. But there's 58 of these integers. That's how many numbers are between 69 and 126 inclusive. Now let's just take a look at this very first one. 69 would yield the divisors 1, which is an appearance for every integer. 3, 23, and 69. Those are the only 4 divisors of 69. Now notice that it has a special factorization here, namely 3, a prime times a prime, and that's it. These are sometimes called semi-prime numbers. And notice one way to get the number is just to increment. In other words, there's 4 right here, right? Well, that's 1 plus 1 times 1 plus 1. And you're essentially just allowing for the exponent of 0 here. You would need to do that just for example, to get the 1, 3, and 23, you'd need an exponent of 0 in there somewhere. Okay? So that product is equal to 4. Now there's another one. So we already have it 1, right? 69 is one of them, okay? And then also the number, if you consider a prime number cubed, and the one in particular I'm talking about is 125. The 4 divisors of 125 would be 1, 5, 5 squared, and of course the number itself, which is 5 cubed in this case. Okay, but that's a general truth that if you have a prime number elevated to, say, the kth power, there's k plus 1 divisors, positive divisors. Okay, now so this would be a tedious task to go through all of these. You know, we've already found 2. 125 has 4 divisors, right? And then 125 is between 69 and 126, right? So we've already found 2, but how do we be more systematic about this, okay? Well, what I've written down right here is kind of a more general explanation of things for this special case of 1 plus 1 times 1 plus 1 right here, okay? So again, we're looking for all primes. Anything in this form is what we're looking for, PQ or p cubed. Those are the only ones that are going to yield 4 divisors. Okay, so the only one, the p cubes would be 125, right? Let's see, 3 cubed is 27, right? 5 cubed, so we're you know, that's it for the p cubed versions. But what we can do is get some mileage out of this pq form. Okay, and just remember what I'm trying to say here is the number of divisors of the product of 2 distinct primes, again called semi-prime, that's always equal to 4. Okay, and again that's just a very special case of this result here. Okay, so I have a partial list already. Now y'all, I started with 2. It's the smallest prime number, and 2 times 37. I'm not even going to write, but I'll write it down, but I'm not going to do it for all of them. This is 74. Notice that 2 times the prime just beneath 37 would be 31. That's 62. Which is not in the list, right? And so what I've done, I've written down what I perceive to be a list of all the 2 times, you know, the prime factorizations involving 2. Okay, so 41 is the next prime number, 43 is the next, and we're just trying to count, remember? 47 is the next one, 53, and if I may be leaving stuff out, if I do, so be it, but anyway, there's 7 of them in this format, 1, 2, 3, 4, 5, 6, 7, I think. Yeah, 1, 2, 3, 4, 5, 6, 7. Okay. Now, so let's we're done with 2. So let's try out 3. Okay, so 3 times. Now we're shooting for the first multiple of 3 that involves another prime that's greater than 69, and I think we've already done that, haven't we? Yeah, 3 times 23. Sorry. Okay, we've already done that one, so let's go ahead and list it. 3 times 23. Okay, what's the next prime after 23? 29, so you have 3 times 29. The next prime, we have a prime pair thing going on here, 3 times 31. Now we have to keep track of how big this number is. This is 93, right? We're not to exceed 126, okay? So 3 times 31 was 37, the next prime. 3 times 37, okay, we have to do some mental math here. That's 111, right? The next prime is 41. Are we staying underneath? Yes, we are. 3 times 41 is what? 123, which is still less than 126. So that'll do it for the multiples of 3, right? So we have 7 up here. We discovered 1, 2, 3, what, 5 more? 1, 2, 3, 4, 5. So now we have 12. Okay, now the next prime number would be 5. Okay, so we already know that 5 cubed is going to be in this list. But what's the small? 5 times 3, 5 times 7, 5 times 11, 5 times 13 is still too small, right? So 5 times 17 is going to get us past 69, right? 5 times 17 is 85. 5 times 19 is 95. 5 times 23 is 115, right? Still doing good? Right? And we have already seen that 5 cubed, which wouldn't technically be in this list, right? But we know that 5 cubed is one, and we'll take that into consideration. So y'all, I think I've got an exhaustive list right here, notwithstanding 5 cubed. So what do we say here? We have 7 in this row. I believe 5 in this row. Let me circle to avoid any ambiguity here. 7 in this row, 5 in this row. 1, 2, 3, 4, 5, right? And we have 3 in this row. Okay. So that's 12, 15. The sum of 7, 5, and 3 is 12. Plus 3 is 15. Okay. And y'all don't forget 5 cubed. Okay, 5 cubed, we did it up here kind of. Yeah, 5 cubed, we did it right here. Has exactly 4 divisors also. And so we have 15 plus 1 equals 16, which is the answer. Now, at least that's the answer I got. Let me know if there's any loose ends. I could have forgotten something or included something that wasn't a prime number. I don't think I put anything that wasn't prime in here. Okay, but the answer I get is 16. Answer I get is 16, folks. So let me come up here and write down 16. And y'all notice we could frame this as a probability question if you wanted to. You could say, what's the probability of randomly selecting a number between 69 and 126 inclusively? Well, there's 58 numbers, so that probability would be 16 over 58. So almost every combinatorics problem is associated with a dual probability problem, okay? 16 over 58. Oh dear, that's what, 8 over 29? Oh good, we got a prime out of that. So we don't have to reduce it anymore. So there's a probability 8 over 29, which is a number less than 1, that this type of thing would happen if you could I think you could simulate this, you know. And also, somebody writes in any kind of computer code, you could just run a iteration structure on this, right? And check the number of divisors and check to see if I made any mistakes. But I did get 16. I'm fairly confident I'm close. It's probably right, maybe off by 1. There's usually when I do things like this, there's something I've forgotten. I think this is 125 is the only one in the p cube form, and I think this other list here of 15. I don't think I made any mistakes there, but it's kind of a clerical task where I may have overlooked something. But in any event, that's it. Again, this is similar to SMO Junior problem. I don't remember the number. I think it was maybe number 4. SMO Junior 2020. Okay, thanks for again.